Alrighty then, corn children, children of the corn. This is repeated integration by parts. That's part 5 of integration by parts, the tabular method. We're going to be making a table. Now, I'm hoping that you really enjoyed part 4, which was repeated integration by parts, because we are really going to repeat it in this one. Take a look. Much like we did in video part 4, this x to the 4th is going to be kind of a conundrum for us. If we let x to the 4th be u, its derivative would be 4x cubed, which means when we go to integrate the second time around, we still have a product of x cubed times trig. So we'd have to do integration by parts again. But the derivative of an x cubed is an x squared, still a product, and so on. So under the conditions where the thing we choose, the part we choose to be the u, will eventually become 0 when we take the derivative, we can use a table method. Let me show you how that looks. I think it's going to be clear. All right, so I'm going to start by allowing u to be x to the 4th. So I'm going to put that in this middle column, x to the 4th. And I'm going to take the derivative of x to the 4th. Well, the derivative is 4x cubed. Okay, derivative again, 12x squared. Again, 24x to the 1st. Again, 24. One more time, the derivative of a constant is 0. Here's your key for this table method. You have to end up with u and its derivatives becoming 0. Hey, play pretend with me for a minute. I'll be a duck. Pretend that that is a negative 4 up there. It isn't, but we're pretending. The derivative would be negative 4x to the negative 5th. It wouldn't go to 0, not even a little bit. So it doesn't happen all the time, but under the circumstances where you have a polynomial, it works out really nicely. All right, now what about these other two columns? Well, let's start with the easy one. Alternating signs. All right, lining these up. First, positive, and just keep going until you reach the 0. Then negative, positive, negative, positive, negative. It's like there's a little pattern. Isn't that cute? I know. All right, dv. This is the hard column. This is the one that's going to make you want to cry a little bit. We chose x to the 4th to be our u. The dv has to be something that's difficult that we can integrate. Believe it or not, we can integrate cosine of 2x. I'm not going to put the dx there, but we know we're integrating those. Now, if you need to, by all means, on the side of your paper or on a separate paper, go ahead and carefully do that integration. Notice, because of this 2x, we have to let u equal to 2x. And we have a teeny tiny u to u, and there's a 2 there. But there isn't a 2 scalar in front, so we have to multiply by 1/2. And when we substitute this all back in, it's the cosine of u. Dx is 1/2 du. Don't forget that 1/2. Integrate cosine, get sine. And put the 2x back. So that's what we get when we integrate. Now, I can do all of that in my head because this is not my first rodeo. But if you need to do that on the side of your paper, 1/2 sine 2x is what goes here. And now we're going to integrate again. Well, once again, because of the 2 here, we're going to have another factor of 1/2. And when you integrate sine, you get negative cosine. So if you integrate this again, it's negative 1/2 times another 1/2 is 1/4 cosine 2x. We integrate again. We have another factor of 1/2. That's not going to become 1/6. We're multiplying. It's going to be a 1/8. When you integrate cosine, it's positive sine. So a negative times a positive stays negative sine 2x. Again, another 1/2, that's going to become 1/16. Integrate sine, get negative, so the negatives will cancel, becoming positive 1/16 cosine 2x. Now keep track of all of our rows here. We need to go one more time. Integrate again. Another 1/2. Integrate cosine, it's positive, times this positive stays positive. Integrate cosine sine 2x. Now, that obviously is tricky. If you need to like stop and go back and do it again, by all means, do so. All right, now we've got this table. How do we put this all together? All right, here's how this works. You take the sine from the first row, the u from the first row, and here's where it gets tricky, and then the dv from the second row. So it's across and down. We don't end up using this at all. That becomes your first term. That is positive 1/2 x to the 4th sine 2x. So I'm going to write that down. Positive 1/2 x to the 4th sine 2x. That's your first term. Here comes your next term. Over and down. The negatives cancel. 4 times 1/4 cancels. You get x cubed cosine 2x. What did I just say? Positive x cubed cosine 2x. All right, try the next one. Over, down. Okay, positive, positive, negative. So first of all, it's negative. The number is 12 over 8 divided by 4. We get 3/2. Yeah. X squared sine. All right, next. Negative, positive, positive, negative. 24/16. You divide by 8 in the top and the bottom, we get 3/2. There's an x and cosine. One more. Over, down. Positive, positive, positive. Plus 24/32. You again divide by 8. What is that? 3/4? 3/4. There's no x. Sine 2x. And then finally, plus c. And that is your answer. It's a beast. I hope it's right. Gosh, that would be awful if it was wrong. I'm double checking. I'm pretty sure that's right. All right, you enjoy that table method. Or as they say in French, tabular method.